Is it permittivity or permeability? Most times we get confused which of them is most suitable to solve problems. The concept of permittivity and permeability will be discussed in this section. What is permittivity? Permittivity is a measure of how easily an electric field can polarize a material. Permittivity can also be considered as the ease with which a material is polarized when placed in an electric field. The symbol for permittivity is epsilon, and another name for permittivity is dielectric constant. Permittivity is measured with the unit farads per meters. What are the various types of permittivity that we have? We can consider permittivity into three different classifications. We have the absolute permittivity, which we also call the permittivity of free space, and it has a constant value which is 8.85 times 10 raised to the power of minus 12 farads per meters, which is actually denoted by epsilon naught. We have the permittivity of a medium, which we also consider as a static permittivity. Different materials have their specific permittivity. Then we have the relative permittivity, which is the ratio of the permittivity of the medium to the permittivity of free space. And that is what we call the dielectric constant. Generally, when we consider the dielectric constant of a material, we are referring to the relative permittivity. It has no units. What does permittivity, what does the permittivity, how does it change with respect to different materials? How does electric field affect or respond to permittivity of a material? If we have a material, when this material is placed in a field where there is no, in a region where there is no electric field at all, that is, electric field intensity is 0, and the electric displacement is also 0, the polarization density is also 0, we see that there is no polarity. The electrons are distributed evenly in their shells, revolving around the nucleus of the atom. But as soon as an electric field is set up, polarization is set up in the material. The atoms become polarized. There is a net polarity of the positive and the negative charges. The positive charges move or drifts to one end, and the negative charges drift to another end. In other words, the charges become aligned based on their polarity. And that principle is what you call polarization. So, we can also now talk about the electric displacement. So, an electric field set up an electric displacement in a material. This electric displacement, what is electric displacement? The electric displacement is the ratio of the permittivity, is a product of the permittivity of the material and the electric field. So, we can say that in a material, as we can see here, the polarization density is, the polarization density here is P, then E, epsilon is the permittivity of the medium, epsilon naught is the permittivity of free space, and the E there stands for electric field intensity. The electric displacement D is related to the electric field with the formula D equals permittivity then E. The epsilon here is the permittivity of the material. Then what is electric displacement? Electric displacement is a measure of the total polarization of a material. A measure of the total polarization of a material when placed in an electric field. It is equal to the sum of the electric field and the polarization field. That is the sum of the electric field and the polarization field. That is what we talk about. So we can say that electric displacement D is equal to electric displacement D can be considered as the permittivity of free space and the electric field plus the polarization. But we have already seen that the displacement on its own, which is D, is equal to permittivity multiplied by the electric field of the material. So if we substitute this, we have permittivity of the material, then E is equal to permittivity of free space, E, plus the polarization density. P here stands for the polarization density, and if we make it the subject formula, we have the polarization density is equal to the permittivity of the medium minus the permittivity of free space, all in the multiplied by the electric field. This is the formula for calculating the polarization field or the polarization density of the material. So the permittivity of a medium is a function of the ability of that material to what? Be polarized when in the presence of an electric field. What is polarization? We have talked about electric displacement, D. Then what is polarization? Polarization is the process by which electric dipoles is set up in a material. The electric dipoles in a material are aligned in the direction of the applied electric field. The diagram which displayed before, we saw that as soon as an electric field is applied to the material, there is an alignment of the positive and the negative charge. The positive and the negative charge of a particular atom constitutes what we call an electric dipole. When these are aligned according to the direction of the electric field, that is what you call electric polarization. Different materials are polarized differently when placed in an electric field. What are dielectric materials? Generally, the concept of dielectric materials is very important in the discussion of electric field. These are materials with high relative permittivity, materials with very high relative permittivity, and they are highly applied in the construction of capacitors, waveguides, and optical devices like optical fibers. Examples of the dielectric materials and their values: we have air having a dielectric constant of 1.0. We have water having a dielectric constant of 80.1. Glass having a dielectric constant between 4 to 10. And we have ceramic with a dielectric constant from 1000 to 10,000. We can see from here that the dielectric constant of materials is a function of the insulating ability, because the dielectric materials are actually insulators. They are insulators, that is, they do not allow charges to flow through them, current to pass through them, but they have the ability to create electric polarization, which means they have the ability to generate an electric field, but they do not allow current to flow through them. These are materials that are used for dielectric. What are the factors that affect the permittivity? Permittivity of different materials can be affected by factors including temperature, frequency of applied electric field, that is the strength of the electric field we're talking about here, and the presence of defects in the material. Presence of defects in the material could be presence of impurities in the dielectric materials or the geometrical construction of the dielectric materials. These are factors that can affect the permittivity of a material. What are the applications of permittivity? Permittivity is very, very important in the field of electricity and magnetism because they are used in the construction of capacitors. Capacitors, which are devices that store electric charges, and the ability of a capacitor to store electric charges is what we call its capacitance. The capacitor is made up of parallel plates, and in between the parallel plates we have a dielectric material, and the capacitance of the capacitor depends on the relative permittivity of the dielectric material between the plates. We also have the waveguides. Waveguides are devices which are used to screen the electromagnetic waves. They help to control or regulate the electromagnetic waves passing through a medium. We have the optical fibers. Optical fibers, these are optical devices. One of them is optical fibers, which is used in the transmission of data, communication data, and it works based on the principle of total internal reflection and refraction. A typical optical fiber cable contains the core, the cladding material, and the insulating material. The relative permittivity of the core and the cladding material goes a long way helping to determine the effectiveness or efficiency of the optical fiber constructed. Let us talk about what is permeability. Now, permeability, on the other hand, is a measure of how easily a material can be magnetized. We have concluded the discussion with the permittivity, and we saw that permittivity is related to electric field. Now we are discussing permeability, and we're talking about the magnetic field. How is this material magnetized? Different materials have different magnetic or magnetization ability. The property of a material to support the formation of magnetic field, that is permeability. It is actually denoted by a Greek letter nu. The symbol for permeability is nu, which is a Greek letter, and the unit for measuring permeability is Henry per meters. Magnetic permeability is defined as a ratio of the magnetic induction to the magnetic intensity. The ratio of the magnetic induction. So if we have mu as the permeability, this is equal to the ratio of the magnetic induction B to the magnetic what? Intensity. This is the formula for permeability. B is the magnetic induction and H is the magnetic intensity of a material. Now we look at what are the types of permeability that we have. We have different types of permeability. We have the vacuum permeability, which is also called the permeability of free space, and this has a constant value of 4 pi times 10 raised to the power of minus 7 Henry per meters. This is the absolute permeability, which is the permeability of free space. Vacuum permeability. We have the permeability of the medium. Here we have mu m, that is the permeability of the medium, and this depends or varies from material to material. We have this is equal to the magnetic induction divided by the magnetic intensity, the permeability of the medium. And we have the relative permeability. The relative permeability is a ratio of the permeability of the medium to the permeability of free space. This is equal to this all over the medium all over that of free space. The ratio of the permeability of the medium to that of free space. That is the relative permeability. That is permeability of medium all over the permeability of free space. It's a constant. It does not have a unit because it's a ratio of two different permeabilities. So these are different. The concept of permeability, which measures the ease with which a material can be magnetized, now help us to classify materials into three different groups based on the ease with which a material is magnetized. One of them is the ferromagnetic materials. These are materials with very high magnetic susceptibility. The magnetic susceptibility is very high, and the magnetic strength is far higher than the what? The magnetic induction is far higher than the magnetic what? Strength. The relative permeability is greater than 1. And when magnetic field lines are subjected or pass through such a material, all the field lines see the material as a point of easy access for the magnetic lines to pass through. So the lines that were moving parallel before, all of them are deflected and concentrated to pass through the material because the material is of high magnetic what? Permeability. Then we have the paramagnetic material. The paramagnetic materials, these are materials that are weakly magnetic. They have the ability to magnetize, but not as high as ferromagnetic materials. It is the relative permeability here is equal or greater than 1. The magnetic induction is fairly higher than the magnetic what? Intensity. Then we have the third material, which is a diamagnetic material. Here, the magnetic susceptibility is very low, very poor. It is weak, it is not magnetic at all. No magnetic susceptibility. And this material, when it is subjected to a magnetic field, it pushes the magnetic field away because the magnetic field prefers to pass through air or vacuum surrounding the material rather than passing through what? The medium itself. So this is a poor a material with poor magnetization power. So, and with this, the relative permeability is less than 1. Ferromagnetic materials. Examples of ferromagnetic materials. What are the uses of ferromagnetic materials? Ferromagnetic materials are used in the construction of permanent magnets, transformers, and electric motor. Examples of ferromagnetic materials that we know in the periodic table, we have the iron, cobalt, nickel, and gadolinium, which are all transition what? Metals with high concentration of unpaired electrons. What permeability? What is the relationship between permeability and magnetization? Magnetization is the process by which magnetic dipoles are set up in a material, and that the relative permeability helps to determine the level of magnetization that we have. And there are some factors that can affect the permeability of a material. What are those factors? The same factors that we mentioned before, which can affect the permittivity, also affect permeability. Example, you have the temperature, we have frequency of the applied magnetic field, and the presence of defect in the material. What are the applications of permeability? Permeability is an important property of material and is used in the construction of magnets, transformers, electric motor, and other electromagnetic devices. Differences and similarities between permittivity and permeability. Permittivity and permeability are two important properties of material, and they relate to the behavior of electric field. One of them, the permittivity, relates to the behavior of electric field, while the permeability relates to the behavior of the magnetic field. Permittivity is a measure of how easily a material can be polarized in the presence of an electric field. On the other hand, permeability is a measure of how easily a material can be magnetized in the presence of magnetic field. What is the formula relationship between permittivity and permeability? The formula that connects permittivity and permeability is the speed of light. The relationship is such that the speed of light c in a medium is 1 all over the root of what? The permittivity multiplied by the permeability of that material. So what does it mean? The significance of this is that the higher the permittivity and the permeability of a material, the lower the speed of light. Because if we look at it, we can see that the speed of light is actually an inverse proportion to each of them, to the permittivity, and also an inverse proportion to the root of what? The permeability of a medium. So these are the relationship. C there is the speed of light, which is 3 times 10 raised to the power 8 meters per second. What are the applications we have mentioned before? Capacitors, inductors, waveguides, and optical fibers. Permittivity and permeability are two important materials, and to summarize the key differences, we can see that one is a measure of polarization, the other one is a measure of magnetization. The both of them affect the electric waves. Electric wave, one of them is for the electric wave, the other one is magnetic wave. One of them is isotropic, while the other one is anisotropic. Permittivity of a medium is isotropic. What does that mean? It shows that the permittivity of a medium remains the same irrespective of the direction of the material. Whether viewed vertically or horizontally, the permittivity of a material remains constant, irrespective of the direction. While when we say that permeability is anisotropic, what it means is that the permeability of a medium is subject to the direction of view. The direction, if we cut it transversely, the permittivity will be different when it is cut what? Longitudinally. So the permeability is a function of, or depends on the material, or the direction with which the material is viewed. Key similarities. Here are some of the key similarities between them. Both of them are properties of material. Both of them are affected by factors like temperature, the temperature and the nature of the material, the design, construction of the material, and the frequency of the wave. All these are affected. Here are some examples of material with high permittivity and permeability. Materials with high permittivity and permeability. For permittivity, we can talk of water and we talk of ceramic. These are material with high permittivity. For permeability, materials with high permeability, we talk of what? Okay, materials with, for permeability, ferromagnetic material are material with what? High permeability. Ferromagnetic materials like iron, cobalt, nickel, gadolinium, these are materials with high permeability. How about materials with very low permittivity and permeability? For permittivity, we have air and vacuum. And then for permeability, we have air and vacuum also. The both of them, they are a material with what? Very, very low value of permittivity and permeability. In conclusion, we can say that permittivity and permeability are two important properties of materials that have a wide range of application. Understanding the differences and the similarities go a long way helping in designing different materials, because the design properties, for instance, when we talk of the capacitance of the capacitor, it's a function of the dielectric material between the plates. When we talk of the efficiency of an optical fiber, is a function of what? The dielectric constant of the material, of the cladding material. When we talk of transformers, is a function of the permeability of the core between the what? The two coils. So different material, the knowledge of permittivity and permeability is a key to understanding of how materials behave in electric and magnetic field. The assignment I want to give to you is, one, I want you to give me 5 key differences between permittivity and permeability. Also, I want you to differentiate between isotropic and an anisotropic material. Make comments in this section, suggest the next topic you want us to discuss, and feel free to ask any question that you want, that you are in doubt, and we will attend to you. All right. Let's call